So for lesson 5, it's radical equations. Basically, we'll split the lesson probably into 2 days. That means we're done everything by Wednesday. So practice test will be Thursday and then your exams on Friday. Make sure that you're practicing these radical operations over the next couple nights so that Thursday you're not feeling like you're cramming. So we'll start off with the domain of a radical expression. So for the first graph, we have this equation here. You could think of it like this: y equals square root x. One of the first things you guys probably are already aware of is, can you take the square root of a negative? No. So could I put in like a -1 here? Could I put in a -2 here? No. So the graph of this equation will only be on the right side of 0. So what's the first one you should try to use? Could you take the square root of 0? What's the square root of 0? 0. So the first point that you could use is right here. That would be when, that would be when x is 0 and y is 0. Could you do the square root of 1? I'm just building a table of values here. Could you do the square root of 1? What's the square root of 1? 1. Good. Because 1 times 1 is 1. So the next point on the graph is right here. It's 1 over and 1 up. What's the next nicest point you're going to get? Square root of 2? Yeah, square root of 4. The best next point would be 4. So then the y value would be 2. So when x is 4, y is 2. What's the next best point you're going to get? When x is 9, y is 3. So it's going to be 6, 7, 8. It's probably somewhere out here. Up one more. It's going to be somewhere like that. And this graph will continue to just grow like this. It grows slowly, and it grows like that. So what would you say the domain of this graph is? Remember that the domain is, if you remember from Math 10, set of all x. So what x values work for this expression? Well, the answer is x greater equals 0. Is there any questions about that? You have your book? Okay. Try to be on time. You can leave it cracked. Alright, so for what values of x is the radical expression square root x defined? Only when x is greater or equals 0, i.e. you can't square root a negative. As long as the x is bigger than or equal to 0, you're good. You guys cool on that? Okay, well, inside that radical house, it's not always just going to be x. Like, look at the next one. The next one is x minus 2. So what's the next one going to be? Start a table of values. Start a table of values. Is 0 going to work? What happens when you put x as 0? What's 0 take away 2? -2. Can you take the square root of -2? No. So what's the first x that you can use? Can x be 1? What happens when x is 1? 1 take away 2 is negative 1. So you can't take a square root of a negative. So can x equal 2? What happens when x is 2? 2 take away 2 is 0. Can you take a square root of 0? Yes, you can. Square root of 0 is 0. So what's the next? Will 3 work? What's 3 take away 2? 1. And then what square root of 1 is 1. So 3 works. What's the next nice point? We need this to evaluate to 4. So x has got to be good. X has got to be 6. What happens when x is 6? 6 take away 2 is 4. The square root of 4 is 2. What's the next nice point? Louder? 11. What happens when x is 11? 11 take away 2 is 9. Square root of 9 is 3. What's basically happened to these points? 0 became 2, 1 became 3, 4 became 6, 9 became... They're all shifted over by 2. So now our graph 2 is 0, so you can draw the point on the graph. 3 is 1, draw the point on the graph. And 6 is 2, you can draw the point on the graph. And you basically get the exact same graph. It's just been shifted over. What's the domain of that relationship? What's the domain for that graph? Remember, the domain is all the possible x values that will work. Can you be left of 2? But can you be right of 2? Yeah, and can you be 2? So then you would say x is greater or equal 2. So then the restriction for x is x greater or equal 2. Because what if you choose a number less than 2? You're going to be square rooting a negative, and that's not cool. So explain how to determine the restrictions algebraically. We're going to take this right here, take the radicand, which we know is x minus 2. And what do you know about the thing inside the radical house? The thing in there has to be greater or equal to 0. You cannot square root a negative. So that whatever's in there, it's got to be 0 or bigger. So what's in there right now? X minus 2. And we know that that's got to be greater or equal to 0. And then you just do a little bit of algebra, plus 2 on both sides. And then you get x greater or equal 2. Just like these ones say. And I'll write it on the whiteboard for you. So this is something that you're going to get tested on. Restrictions. Square root x. X has to be greater or equal 0. In other words, radicand greater or equal 0. And then solve. And remember, hint, x can be any expression. So you'll see what I mean in this next question. So C triple I. the radicand has to be greater or equal 0. Because you can't square root a negative. The radicand in this case is 3 take away 2x. Do a little algebra. I'm going to move the 2x to the other side. Then you get that 2x is less or equal 3. Now what do you think I should do to solve for x? Not minus 2. Good, divide by 2. And then you get x less or equal 3/2. Okay, so we're going to practice this for a while because there's some little details on this. So class example 1. Class example 1 is this title here. Restrictions. You'll get asked to determine restrictions. And you follow this pattern here. Square root x means that the x has to be greater or equal 0. But remember, x could be any expression you wanted. So basically, it's the radicand is greater or equal 0, and then solve that. So for the first one, what's the radicand? Good man. X minus 2, right, Tia? So then all you have to do is put x take away 2 greater or equal 0. And then you solve that, just like it's a regular old equation. You want to isolate the variables, so negative 2 has to go to the other side. How do you do that? Good, plus 2 both sides. X is going to be greater or equal 2. Just as a reminder, do you see how the symbol's opening up this way, like the crocodile's opening up that way? So that means x is greater or equal to. So can x be 3? Can x be 3? Yes. Could x be 4? Yes. Could x be 5? Yes. Could x be 0? Could x be 1? Okay, you guys understand that. Okay, next one. What's the radicand? 4x plus 1. What do you know about the radicand? It's got to be greater or equal to 0. Whatever's in there, whatever this becomes, it's got to be 0 or bigger, right? Because you can't square root a negative. So we're going to solve this. 4x plus 1 has to be 0 or bigger. How do you write that? Greater equals 0. And then this is just equation solving practice. It's plus 1 on the left, so we have to go minus 1, minus 1. Then we get 4x is greater or equal negative 1. This is just equation solving practice. There's a 4x. We want to make it 1x, so we have to divide by 4. Then you get x is greater or equal negative 1/4. Good for the next one? This one looks a little bit different, but it's the same process. What's the radicand? The radicand only is 2 take away 5x. And what do you know about that radicand? It has to be what? Greater or equal to 0. Now this one's really the weird one. This one's weird. You have two options, right? You could leave the negative 5x and send the 2 over. Or you can send the negative 5x over there. So this is where it gets really dicey, especially with inequalities. If you leave the negative 5 on the left and then divide by a negative, you have to flip the inequality. It's really weird. Let's just do something for fun. Negative 7 is less than negative 6. Is that true? Divide both sides by negative 1. Is that okay? Whatever you do to the left, you do to the right? That's okay, right? So then the negatives cancel, and then you get 7 is less than 6. That's not true. So when you divide by a negative, you have to remember to flip the sign. Are you guys going to remember that? So if you are not going to remember that, if 9 times out of 10 you're not going to remember that, that's your confidence level. What you can do to solve that issue is just move the 5x over to the other side, and then you don't ever have to worry about dividing by negatives. So what did I do? All I did on both sides was add 5x. Right? Now, you just divide by a positive, and you never have to worry about flipping signs. Show you the other way. 2 take away 5x greater equal 0. Negative 5x greater equal negative 2. Because I send the 2 to the other side. Divide by negative 5. Divide by negative 5. Those cancel. You get x is lesser equal 2/5. Those negatives cancel, and then the sign has to flip. It's the same. And then the last one, and this is where you'll probably get rattled on this one. This is not on my test. I don't want to mess with you guys. Can you take the cube root of a negative? You can, right? You can take the cube root of a negative. So cube roots are different. They're not like square roots. Right? If you did a negative times a negative times a negative, it can become negative. That's okay. So there are no restrictions on this one. Do you guys know how to write no restrictions mathematically with symbols? That thing. You probably recognize that. That's an x element of the real number system. Basically, x can be any number. that you can possibly think of at the high school level. X is any real number. It could be an integer, it could be a decimal, it could be negative, it could be irrational, it could be anything. Now, as far as studying for tests, it'll be A, B, and C. This is what I'll test you guys on. A, B, and C. And now comes the equation solving. Let's flip a couple pages ahead. Okay, class example 3. The class started with this topic. We're doing restrictions. This would be called solving equations. Before we start, I'm just going to do a little warm-up activity for solving radical equations. Do you guys remember Pythagorean theorem? If you know the two legs of a right-angled triangle, how do you solve for C? Like if A was 3 and B was 4, how would you solve for C? You would have to square them, add them, and then what? You'd have to square root, which cancels that, right? So in a similar fashion, if you had an equation involving a radical, how do you get rid of this radical sign? This is a square root, so you have to think to yourself, like, what's the opposite of square rooting? Squaring. Just like up here, what's the opposite of squaring? Square rooting. Well, what's the opposite of square rooting? Squaring. And they got you started here. So they square both sides. Oh gosh. All right. So what happens when you square a square root? What happens when you square a square root? For example, what's 5 squared? 25. And then what happens when you square root 25? You get... They undo each other, right? They call that inverse operation. What's the inverse of plussing? Good. What's the inverse of timesing? What's the inverse of squaring? Square rooting. So what happens to this equation is like the square and the square root cancel, and you're just left with x plus 2. And then this equals x squared. And then this opens up a whole nother can of worms. Because this is a degree 2 equation. How do you solve degree 2 equations? You might remember this. I don't know if you guys know this at all. You have to make the left side 0 know if we're going to be able to go on Friday. This opens up a whole nother can of worms. Gummy worms? That would be nice. Every problem you ever faced in your life was gummy worms. All right. Do you guys remember how to factor? Oh gosh. I'm just going to put the answer up. You want to just use a calculator? Okay, I'm just going to leave that up for a few seconds so you guys can think about it. This occurred in Math 10C for you guys. Long time ago. Yeah. So you need basically two numbers that times to -2 and two numbers that add to -1. And what are those two numbers that multiply to -2? -2 and +1. Yeah. And then those are the factors. Okay, so this is called factoring. Factoring trinomials. All right. Now I want you to think about, well, first of all, are you guys okay with the factoring? Can we just check how this works on the side? X times x is x squared. X times 1 is 1x. -2 times x. And then -2 times 1, negative. And then these guys are like terms. X squared minus x minus 2. If I gave you these two things in a bracket and I ask you to FOIL it, a lot of you guys will have no problem with that. But if I ask you to do the reverse process where I give you the trinomial and ask you to find the two factors, it's a little bit tougher. Listen, let me pause the video. Now I want you to think about this equation on the right and this equation on the left. How are you going to make this equal to 0? And you're multiplying. See how it's this times that? This is multiplication. So how do you multiply and then end up with 0? One of these factors has to be. How do you multiply two numbers and get 0? Times it by 0. So one of these or both have to be 0. So what value of x will make this one 0? Two. What would happen if x was 2? 2 take away 2 is? Then you'd have 0 times, looks like 3. 0 times 3 is 0. What's the other answer? -1. Now we got to go check these answers. We got to put these answers back into the equation. So what if we put 2 in there? Guys, come on. 2 plus 2 equals 2. Square root 4 equals 2. 2 equals 2. So it looks like this one's good. What about the other one? What about the other one? Check the other one. Square root, we got to put in what? A negative 1? Negative 1 plus 2, and this is going to equal negative 1. Square root 1 equals negative 1. 1 equals negative 1. So only one of those works. So what this brings up is this word right here. See that word? Have you ever heard people call somebody extra? So I don't exactly know what you guys mean by that when you say someone's extra. For me, it means like it doesn't count, like it's extra. You don't need it. It's not. You don't need it. So this word here, extraneous, when you do all this algebra and then you get an answer that doesn't work, that answer is extra. That answer is extraneous. This answer doesn't work. So when we do these radical equations, you guys, we always have to check if it worked. Because remember the beginning of the lesson had restrictions? Remember the restrictions? What if our answer doesn't meet the restrictions? So we always have to do a check. We always have to do a check. And I checked my exam. If you're watching this at home, I checked my exam. You're going to have none of this on the exam. You will not have to do factoring or degree 2 equations on the exam. That's for the next unit coming up after. Okay. So steps for solving. Steps for solving. First, you're going to isolate the radical. If you go quickly, because this is the most important part of the whole lesson. First, you're going to isolate the radical. Then you're going to square both sides. Then you're going to solve. And then you're going to check. Okay, the first question, folks, it's already isolated. So we can skip step 1. We're going to square both sides. And we get that x plus 3 equals 49. Look at that equation. Is that degree 2 or degree 1? It's degree 1 because the power on x is a... It has nothing in common with this thing we just did. See, this one was degree 2. This one has the power 2 on the x. That makes things a whole lot trickier. This is the stuff we've been doing since junior high. You know, you put the numbers on one side, x is on the other. So all we have to do is move the 3 to the other side. Take away 3, you get x is 46. Now we check. And you will have a part on the exam where there's like a box that you have to check. You have to do this to get the full mark. Okay? So we're going to take our answer and we're going to plug it back in there. So we get the square root of 46 plus 3, and we're going to check question mark if that equals 7. Square root 49 equals 7. 7 equals 7. Yay. You just put the number that you solved for back in there. 46 plus 3. No worries, big guy. Okay. For part B, question B, the radical's not isolated. The radical's not isolated. So if you take a look at step 1, what does it say? Isolate. Look at this radical. Is it isolated? I need this guy alone. Kind of like my Friday nights. So subtract 7, subtract 7. All right. So I've isolated the radical with math, yep. Now what's the second step? Square both sides. The best part about squaring a square root is that it just goes away. See you later. But the right side, it's like this one. You have to write it twice and then FOIL. Because you're squaring the expression x minus 7. So that means you have to write x minus 7 how many times? And then this is the style of equation that's not going to be on my exam. Because look what happens. You go x times x is x times negative 7, negative 7 times x again, and then positive 49. You guys, we did foiling earlier this week, or was it last week? X times x, x squared, x times negative 7, negative 7x. Then you go on the inside, negative 7x, and then positive 49. Definitely collect like terms. And then this is a problem. It's degree 2. It's like this one. It's like this one. Is that going to be on your test? No. So this book is just giving us a little bit extra work. Okay, we're going to put 0 on the left because x squared here is positive on the right. So we want to put everything else on the right. So I got to subtract 49 and add x. So if I add x, I get minus 13x. And if I subtract 49, I get 0. Good. Subtract 49 and add x. Subtract 49 and add x. Now I have to factor, which you're not going to have to do on my exam. So don't stress. This factoring is a little bit different than the factoring we did on the board. This is factoring a trinomial, but this one is just a GCF. This is just a greatest common factor. See how they both have x in common? They both have x in common, and that's the only thing they have in common. So I factored it out to the left. Now do you know what the answers are here? What's going to make the right side 0? Positive 13 and 0. If x is just by itself, It's just 0. But if x is written as a binomial, like that, it's just the opposite. Now we got to go check those answers. It's ridiculous, right? I will show you which exam questions are reasonable test level. So this book is going a little bit beyond. So check the first answer. 49 take away 0 plus 7 equals 0. The square root of 49 is 7. 7 plus 7 does not equal 0. So the first one is extra. Extraneous. Extraneous. Or extra. Extraneous. Okay. Let's try 13. 49 take away 13 plus 7 is apparently 13. What's 49 take away 13? Oh my gosh. 36. Beautiful. Square root of 36? 6 plus 7? Oh. So this one's a happy face, okay? X equals 13. Yes. We're not going to be doing cubes, so don't worry about cubes. And for the assignment, please pay attention for the homework assignment because there's some stuff that's not necessary for you guys to wrap your heads around. So number 1 for sure, absolutely number 1. Don't worry about 2 and 3. Okay, so we said number 1, and I like number 4, but you just have to do part I. You don't have to solve it graphically. So part I is just this restriction stuff. So for part I, this is what you need to check. I got you started on this one. And again, don't worry about the cubes because we're not going to have cubes. And you don't have to graph it. Just solve those inequalities. And definitely number 5. But only do ABC. Oh, careful. Just give me 1 minute. It's hard to get off. And don't worry about 6. Don't do it, Leighton. Don't do it. Okay, just give me 1 second. Just give me 1 second. Don't do it. Okay, guys, right here, please jot this down. This is your homework. Okay? Number 7, there's something like number 7 on the exam. That's why I want you to try 7. But as far as the difficulty level goes for equation solving, 5ABC and 1. Square both sides, solve for x. None of that degree 2 quadratic stuff. None of this factoring stuff. So we're definitely still on for Friday. This is happening. Absolutely it is. So that means tomorrow and Thursday, 100% review. You'll have my review package as well as the review package in the book. The practice exam. This lesson I thought we'd split, but it's not in the it's not splittable. Okay, good luck.